Development environments. There are many programs that support the development of Java software. This includes Sun Java Development Kit, or JDK. You have Sun NetBeans, IBM Eclipse, Borland JBuilder, MicroWorks CodeWarrior, BlueJ, and JGrasp. Though the details of these environments differ, the basic compilation and execution process is really the same. Syntax and semantics. The syntax rules of a language define how we can put together symbols, reserved words, and identifiers to make a valid program. The semantics of a program statement define what that statement means. So basically, its purpose or role within a program. A program that is syntactically correct is not necessarily logically or semantically correct. A program will always do what we tell it to do, not what we meant to tell it to do. That is important to remember, because basically whatever you tell the computer to do, it's going to do. If you wanted it to do something else, you need to specify that. If you don't, it will not be able to do it because it can't assume what you wanted. So let's discuss errors. As you know, there is human error within writing any kind of program. Within a program, you can have three types of errors. The compiler will find syntax errors and other basic problems, compile time errors. If compile time errors exist, an executable version of the program will not be created. A problem can occur during program execution, such as trying to divide by 0, which that will cause a program to terminate abnormally, and that gives you runtime errors. Now, a program may run but produce incorrect results, perhaps using an incorrect formula. This is logical error. Here's an example of basic program development. Please take a moment to look at the animation. Now let's discuss object-oriented programming. Problem solving. The purpose of writing a program is to solve a problem. When you solve a problem, this will consist of multiple activities. These are understanding the problem, designing a solution, considering alternatives and refining the solution, implementing the solution, and testing the solution. These activities are not purely linear. They can overlap and interact. Within problem solving, the key to designing a solution is breaking it down into manageable pieces. When writing software, we design separate pieces that are responsible for certain parts of the solution. An object-oriented approach lends itself to this kind of solution decomposition. We will dissect our solutions into pieces called objects and classes. Object-oriented programming. So Java is an object-oriented programming language. As the term implies, an object is a fundamental entity in a Java program. Objects can be used effectively to represent real-world entities. For instance, an object might represent a particular employee in a company. Each employee object handles the processing and data management related to that employee. Objects. An object has states and behaviors. A state is descriptive characteristics, and behaviors basically what it can do or what can be done to it. For example, the state of a bank account includes its account number and its current balance. The behaviors associated with the bank account include the ability to make deposits and withdrawals. Note that the behavior of an object might change its state. Classes. An object is defined by a class. A class is a blueprint of an object. The class uses methods to define the behaviors of the object. The class that contains the main method of a Java program will represent the entire program. A class represents a concept, and an object represents the embodiment of that concept. Multiple objects can be created from the same class. So data and expressions. Below are some examples of data and their expressions that you will find in Java. You have character strings, variables and assignment, primitive data types, expressions, data conversion, interactive programs, graphics, applets, and drawing shapes. Character strings. A string of characters can be represented as a string literal by putting double quotes around the text. For example, this is a string literal, 123 Main Street, and the capital letter X. As you can see, your character strings are all different sizes and, as stated earlier, have quotes at the beginning and the end. Every character string is an object in Java, defined by the string class. Every string literal represents a string object. So let's discuss the println method. In the Lincoln program from earlier, we invoked the println method to print a character string. The system.out object represents a destination, the monitor screen, for example, to which we can send output. So in the example, you have your object with its system.out, your method name, which is println, and then the information provided to the method, or your parameters, which is whatever you are, be a good one. The system.out object provides another service as well. The print method is similar to the println method, except that it does not advance to the next line. Therefore, anything printed after a print statement will appear on the same line. So if you take a moment, look at the example in the code below on facts.java. You will notice that there are several systemout.println examples within this code. Escape sequences. What if we wanted to print a quote character? The following line would confuse the compiler because it would interpret the second quote as the end of the string. So within the brackets you see I said, then another quote, hello, and then the final quote. If you printed this out as is, the only thing that you would see on the screen is I said. An escape sequence is a series of characters that represents a special character. An escape sequence begins with the backslash character. So if you take the same example from above and add the backslash character, you will then be able to display the entire example. Escape sequences. Here's some examples of Java escape sequences. Please take a moment to look at these. Here's another example of the backslash in action. In the roses.java example, you will see that there are multiple statements that have the backslash and the double quotes in them. This allows you to display your entire line Please take a moment to review this. Variables. A variable is a name for a location in memory. A variable must be declared by specifying the variable's name and the type of information that it will hold. If you will note in the example below, multiple variables can be created in one declaration. Variable initialization. A variable can be given an initial value in the declaration. int sum equals 0, and then int base equals 32, max equals 149. When a variable is referenced in a program, its current value will be used. Take a look at the example pianokeys.java. You can see in the example you have int keys equals 88. Take a moment to review this example. An assignment. An assignment statement changes the value of a variable. The assignment operator is the equal sign. As you can see in the example below, total equals 55. The expression on the right is evaluated and the result is stored in the variable on the left. The value that was in total is overwritten. You can only assign a value to a variable that is consistent with the variable's declared type. As you can see in the example geometry.java, there are several examples of this. Please take a moment to review the example. Constants. A constant is an identifier that is similar to a variable except that it holds the same value during its entire existence. As the name implies, it is constant, not variable. The compiler will issue an error if you try to change the value of a constant. In Java, if we use the final modifier to declare a constant, final int min height equals 69. Constants are useful for three important reasons. First, they give meaning to otherwise unclear literal values. For example, max load means more than the literal 250. Second, they facilitate program maintenance. If a constant is used in multiple places, its value need only be updated in one place. And finally, they formally establish that a value should not change, avoiding inadvertent errors by other programmers.